So in this video, let us solve question number 1 of exercise 5.1 of the continuity chapter. Question is, prove that the function f of x is equals to 5x minus 3 is continuous at x is equals to 0, at x is equals to minus 3 and x is equals to 5. So we have to prove the continuity of the function 5x minus 3 at different points. So let us find the solution. So from the definition of continuity, we know that the given function, suppose consider the function f of x is continuous at a point C if its left hand limit is limit extends to c minus f of x is equals to right hand limit, that is limit extends to c plus f of x is equals to the value of the function at the point C. If the left hand limit is equals to right hand limit, so that is equals to the value of the function at that point. If all these are equal, we can say that the given function is continuous at that point. Again, the definition of left hand limit can be written as limit h tends to 0 f of c minus h. Right hand limit can be written as limit h tends to 0 f of c plus h, that is equals to f of c. So either we can use any one of these two definitions to solve the given problem. So here given f of x is equals to 5x minus 3. So let us check the continuity at the point 0. So that is x is equals to 0. So the value of the function at the point 0 becomes f of 0 is equals to 5 into 0 minus 3, that is equals to minus 3. Now compute the left hand limit. So left hand limit is equals to limit extends to 0 minus f of x, that is same as limit h tends to 0 f of 0 minus h. So the point is 0 here. Instead of c in the definition, we are taking 0. So that is equals to limit h tends to 0 f of 0 minus h. f of x is equals to 5x minus 3. f of 0 minus h means we have to replace x by minus h. So that is 5 into minus h minus 3. Now replacing h by 0, that is substituting the limit, we get 5 into 0 minus 3, that is equals to minus 3. So left hand limit we obtained minus 3. Right hand limit of the function at the point 0 in from the definition of limit. Right hand limit is equals to limit extends to 0 plus f of x. So that is equals to limit h tends to 0 f of 0 plus h. So instead of c, we are taking 0 in the definition of limit. So that is equals to limit h tends to 0 f of h. f of h will be 5h minus 3. Now replacing h by 0. So what will get 5 into 0 minus 3. So that is equals to minus 3. So left hand limit we obtained minus 3. Right hand limit also we obtained minus 3. Also the value of the function at the point 0 is minus 3. So clearly what we can say, left hand limit is equals to right hand limit. So that is equals to the value of the function at the point 0. So all these are equal. So what we can say implies f of x is continuous. The given function is continuous at x is equals to 0.